energy. We could say it is one energy really. As it breaks into two, some of it stays outside and between the outside of the objects. And if the internal structure, some of the energy goes inside the external interaction. So, this is another way of looking at the TOE and the fifth force. I call that the fifth force, when all the forces join together at the beginning of the universe. We hear of a speed of light. This is another speculation. Let's speculate on that. So, we read every day that 300,000 per second. That's the matter can travel up to 300,000 kilometers per second. That's the speed of light. What it means a particle such as photon or gamma rays, all these particles in the universe, they travel at 300,000 kilometers per second, and there's no other speed bigger than that. In other words, if something is speed up to the speed of light, its structures just dissolves. So much so even the atom cannot at that speed exist. It breaks down into particles. So it is like almost like the law of the thermodynamics that the entropy increases with the speed. As the speed goes higher, the structure dissolves, disintegrates to the time that it becomes a particle. It's like a photons. So, and that is the speed of light. And that's final. There can't be no more speed bigger than that. I'm again speculating philosophically, and I'm saying that if a proton, as they're trying to do it in CERN in Europe, proton accelerator, accelerate these protons up to 300,000 kilometers per second and try to collide it with each other to see if it can broken down, if it can breaks down into quarks, which is the component of the proton. In that case, proton, which is made out of quarks, if we speed up the proton, which we can't, because they say 300,000 per second, that's it, that's the constant speed. If it breaks down, when it turns into a quark, I don't know if they could break it down or not. Now the quark, which is smaller than the proton, again, it would have to be going with the higher speed. Because as I just said, entropy increases in the speed, with the second law of thermodynamics. So, as we speed, the structure disintegrates. If the structure is atomic structure of a particle, such as proton, made out of quarks, with the higher speed, it has to be broken down. And if we go on, future, who knows, to say that quarks are also made out of subquarks, and that's so on and so on and so on. So we can basically go on and break it down to such a small things that right now is not even imaginable. Which I come to the speed. Abdul Baha'i again, the master of universe, he says that the speed of imaginations, wow. He says imagination has a speed. What is the carrier of that force? Sure, the imagination is done by the soul, not by the brain. That is the Baha'i concept we'll discuss later on. But the manifestations of the imagination has impact on the body. Anything a man does behind a computer, it will have an impact on the screen of the computer as we type. We're not in a computer, we're outside, but we type, it does have an impact as we type. So as we imagine our soul, it will have an impact on our body. And as we imagine, something happens in the body that we can imagine. Something has happened in the past, or sometimes we imagine things in the future. So, could we imagine, could we say that the speed of light is really the speed of particles, and particles are made out of subparticles and smaller, so on and on and on? As we increase disintegrating the structures of the matter, smaller and smaller, we increase in the speed. We can increase the speed. And we can reach to a particle that would be called imaginum, let's say. So sometimes I say to myself, because we are electron-based equipment that we have, this is why we can't get messages in the universe. But if we were quark-based machines, that was not electron, it was the quarks that was the basis for this machine that we have, we would hear a lot more voices and noises in the universe. Because how else could we travel in this universe? With the speed of light, we can't go anywhere. 12,000 years it takes to just get out of one end of the Milky Way to the other. And this is only one galaxy in our local group of galaxies. And there's literally millions of it, of galaxies. So if material can and should be able to understand, to go around this universe, know what's happening, it can be using the speed of light, which is the speed of particle. It has to be a higher speed. For that, we have to imagine, therefore, as it is there, the speed, higher speed, would be the speed of matters smaller than particle. It would be quarks, and smaller and smaller. I will call that particle imaginum. If we can use imaginum particle, as in the imagination, and understand it, and try to put our brain in a situation like that to control this power, then we can see the past, and sometimes even the future. We can literally go to a dream and sleep and have a dream, and we get up and say what's happening in the universe. And this can happen several times by several people in different rooms, and the results are very similar to each other. And that is the only way I think we can travel the universe. That's one way of speculating the speed of imagination. That's what Abdu'l-Baha uses, that word. So it could be in a speed of the matters much smaller than quark. Let's talk about another one of these. It's called the uncertainty principle. That's pretty unique things too. I think it was Werner Heisenberg that he proposed that there is an uncertainty principle pertaining to the velocity and the position of the electron. If a photon of light excites an electron in the atom, it goes so fast that it turns into a circle, like a cloud. You can never know where is the electron. You cannot position it. But you know the speed. It's what velocity of the electron. But you know what the speed is. It's much like you take a picture from a car, on a racetrack. If you focus on the car, the background of the audience will be blurred. And if you take the picture of the audience, the car will be blurred. You can't focus on both of them. One is moving, one is silence. So he said, well, Einstein heard that and he said, God doesn't play dice. This can't be. But later on, it was proven no. That is not the case. There is such a thing, and God plays dice and plays very good too. But I, as a philosopher, I listen to this and I hear it, and I say to myself, is this uncertainty principles the limitations of us as a human being to understand the position and the speed of the electron at the same time, or it is a natural phenomenon? I think it is our limited ability. We cannot focus on both things at the same time. I'm saying that if we were small enough, if we had a device small enough to put on the electron, and when it speed up, then we would know exactly where we are, our position to the nucleus at any time, and also we would know our speed. So, uncertainty principle, which is very much a part of the quantum mechanic, I'm arguing that it's a definition of our limitations, not really the actual factual fact of the nature. So as I hear these differences in time differences, it is a matter of fact that time in an airplane goes faster than in the earth. It's a proven fact. If you're underground in the ocean, time slows down much faster than the one in the airplane. The other day I was looking at a program and said, well, when you're closer to the pyramid, because it's a huge object, time slows down. And I'm saying to myself, no. Time cannot slow down. Time is a virtual thing. Time is the measure of the motion. When something happens from point A and B, when the A reaches to B, we say this is the time taken for A to B. So when we're saying time, we're always representing time by matter, by clock. So this is the clock, which is material, is slowing down as it gets closer to the gravity. Gravity slows the matter, not the time. So the motion is slowing down, not the time, really. That makes sense. That gravity slows the matter, and matter moves slower. Can't. In the moon we can jump fast because the gravity is not as big. In here we can't. Our motion is slower in the earth than it is in the moon. So time delaying and time differences and that fact that time is slowed down by gravity and all of that, not acceptable to me. I think what's representing the time is slowing down, which is the clock made out of matter. Matter is slowing down. So motions are slowing down by the gravity, and we look at the time clock, whatever we measure the time, but if we see it's the matter that's slowing down. That's again my speculations. There is a affinity. Probably my scientific explanation as a philosopher, it is the same as Mr. Hawking says, oh, that 6 days is the Ice Age. Probably 10,000, he said, and I wrote down 6,000. And I explained before that there's no such thing. 6 days is a reference to 6,000 years from Adam to Muhammad to the Baha'i faith. 6,000 years of the religious matters, nothing to do with physics, physicality. So probably just as his explanation philosophically and religiously are way out of whack, so is probably my scientific explanation, but I'm using philosophy. This is how I deduct from what I see. I remember one time I was watching a CD on the string theory with my son. It was a sophisticated explanations of so many dimensions in the world. I don't know, 22 dimensions and all that. And we were arguing, me and the son. I said, Dad, I have no dispute about these mathematical calculations. But it does not pertain to reality. We can imagine an imaginary building as an engineer, calculate how to build this up.